Okay, so communications tower located at the top of a steep hill shown below. And that picture is not drawn to scale. Clearly that ain't 78 degrees and that's not 7 degrees. Okay, so it's not drawn to scale. The angle of inclination of the hill is 78 degrees. The guy wire is to be attached at the top of the tower to the ground 150 feet downhill from the base of the tower. Okay. The angle formed by the wire is 7 degrees. Find the length of the cable. All right, what can we do with this? So let's play around. So they've put the relevant information in here. It's just not drawn to scale. I don't think I'm going to redraw it. And then we have the base of the tower. If we come straight from the top, then it's going to hit right in the middle there. So that's really our triangle here, right down the middle. And then this distance is 115, that's 7. And then we have this angle here at 78. So if that angle right there is 78, and you think about this perpendicular, which matches that one, right? Parallel lines here. Then this angle right here with the 78 has to make 90. So if I take 90, oops. Oh, come on, give me a pen, please. There we go. 90 minus 78, that's going to give me 12 degrees. So this angle right here, from here to here, has to be 12 degrees. And does that help? Let's see, I need to know either this angle up here or this angle down here. So maybe that line isn't the one I want. Let's draw another line. So this point is important. So I'm just going to draw a parallel line to the ground here. Okay, that might be more helpful. Check this out. So this line right here is parallel to the dotted line. And then from this angle, this line right here transecting through there, this angle right here inside has to match that angle right there. So that part has to be 78, and then I drew that to be 90 right there. So this whole inner angle right there has to be 90 plus 78 degrees. So I got to use a little basic geometry to figure that out. So let's see, 90 plus 78 is 168 degrees. So that's that angle. So just kind of pull this off to the side. I've got this triangle totally not drawn to scale. They're saying that's 7. Based on this angle of elevation here, I have that obtuse angle right there has to be 168. And now I know this upper angle right there, it's going to have to be 180 minus 168 minus 7. So let's see. 168 plus 7 is 175. To get to 180, this would have to be 5 degrees up there. I know this side right here is 115, and I want to know that side right there. So law of sines tells us that if I'm looking for that side, I have to divide by the sine of its opposite angle. And then that's going to be equal to another pair. So then to use the 115, I have to go to its opposite angle, which is 5, sine of 5. And then multiplying that sine of 168 up, that guy wire has to be 115 times the sine of 168 divided by the sine of 5. And this picture would be a hard one to draw to scale. It's doable. It's just we have to work in a length of 115 and then these little tiny angles of 5 and 7. So this triangle is going to be way taller and narrower than it appears in my picture here. But it is doable. And that's the length of our guide wire. Plug it into your calculator. Make sure you're in degree mode. Super important. Check that every time you make a calculation with sine, arcsine, cosine, and so on. So the hard part here was trying to figure out how to use that 1/78. And often with these problems, we're going to use perpendicular and parallel lines to transfer angles to other places and use some basic geometry from your past life in math, like alternate interior angles, alternate exterior angles, corresponding angles, vertical angles. Do you guys remember all those? We should probably do a quick review of those for fun. Since I mentioned it, I might as well do that now. All right, so in a lot of application problems, you got to use your past life in geometry. So if you have a pair of parallel lines and then a line transversing through them right there, then there's lots of special angles. So for example, this angle, oops, my pen back, this angle right here is going to be equal to that angle right there because those are called alternate interior angles. This angle right here is equal to that angle right here because those are called corresponding angles. They're in the same position with each other. This angle right here and this angle right here are equal. So again, if I focus on this angle right there, let's use green maybe, then terminology is this one up here is an alternate interior. This one right here is called a corresponding angle. This one right here is called vertical angle to it. And they're all congruent. If we focus on this vertical angle right here, let's use a different highlighter on that one. That angle right there compared to this one up here, those are on opposite sides of the transversal and they're outside of the parallel line. So those would be alternate exterior angles is the other kind of relationship that comes up here. So again, this angle here, choose maybe red. Red, please. And this angle here are alternate exterior angles, and they're also congruent. Other relationships that are important here is the idea that this given angle I started with over here and this angle right here, these two have to add up to 180. So that means they're supplementary. And otherwise, that supplementary has an alternate interior angle. It has a vertical angle. It has a corresponding angle to it that are all congruent. So whenever we have a pair of parallel lines and a line transversing through them like that, we basically have two angle measures that are located in all those different places right there. So if I know one of those angles, I then know all of the angles, right? So just a quick example on that. So let's draw another pair of parallel lines down here. Oops. And a transversal. So if somebody told me that this angle right here was, say, 30 degrees, oops, then I know that this one is 30 degrees, and this one is 30 degrees, and this one is 30 degrees. And then I also know, because of the supplementary aspect, that this angle right here would have to be 150 degrees. So alternate interior, this would be 150. Corresponding, this would be 150. Vertical, this would be 150, right? So I know all of the angles involved in that. So that's used a lot when we have to move angles around in a situation that has multiple triangles in it.